So hey guys, I hope you're doing well. Today in this video, we'll be talking about balanced binary trees, which is a type of binary tree. And I had already discussed this topic. It was a very quick session, so I couldn't dive deeper into it. So let's discuss this in detail. And at the end of the video, we'll be also solving a LeetCode question, which will be very beneficial for you, right? So, okay, balanced binary tree. Let's start with an example first. So let's say we have a tree 1, 2, and 3. Let's take 4 here. So, how you're going to uh, conclude this as a balanced binary tree or an unbalanced binary tree? So, let's see that we have 1 here, which is the root node. We have 2 here, we have 3 here, we have 4 here, right? So, if you take this node, this part of the node, which is only 2, there's only one node. And if there is only one node, we take the height as 1, right? And if you take the right half of the node, or right after the node root node, we take the height as 2 because there are only two nodes, 2 and 4. So this whole height is 2. This whole height is 1. And if we take the difference between those heights, which comes out to be 1, if this comes out to be 1, this is called a balanced tree. Actually, more specifically, if this comes out to be less than or equal to 1, this is called a balanced tree. And you can take any difference like left half and right half, or right half and left half. It will come as the absolute value anyways, right? So this was an example of a balanced binary tree. Let's take an example of unbalanced binary tree. So if we say unbalanced, let's take a node here. This height will be 3. This height will be 3. And if the difference between the heights is more than equal to 2, don't worry about the sign, it will be absolute value, right? So if this comes out to be more than 1, which is 2, more than 1, which is 2, 3 minus 1 is 2, right? So this is called an unbalanced binary tree. But that's not how you check it. What if, oops, okay, so what if it was like this? Okay, what if it was like this? Then this height would have been 2. This height would have been 2. This would have been an balanced binary tree. Why? Because you check each node. Here there is 1. Here there is 2. Only with respect to 1. Only with respect to 1. If we say we have to check for each node, let's say we are checking for 2. 2, there is neither left half or right half. So the difference is 0, which comes out to be balanced, right? This, let's check this 3. This 3 has 1 here, 1 height here, which is 4, and no height there. Let me just clear it up. My duster, okay. Okay, so we have here 4, and if we check with respect to 4 here, this is 2, and this half is 0. So this comes out to be unbalanced binary tree, right? Unbalanced binary tree, because the difference between this height and this height is more than 1. More than 1. You have to keep this in mind. And that's how we are going to check each and every node here, right? So we have to keep certain things in mind. Let's say this half of the node, this node 2. 2 has neither left half or right half. So it's going to print 0. Why? Because it's the left half is null. This is null. The right half is null. This is null, this is null. This is going to return 0, which you are going to understand in the code. I'm just telling it here. So not here we are going to return 0, here we are going to return 0, because the height is 0 here, right? This one condition, and we'll be calculating the left half and right half of the node in the code. And yeah, um, I think that's it you need to that's what you had to keep in mind, and we'll dive towards the code. Thank you. We'll be implementing the code here, and the first thing which I'm going to do is I'm going to define g node star node, which is equal to root, and I'll be passing a function which can be let's say length, where I'll be passing node 0 and 0. This 0 0 are nothing but the left half of the node and the right half of the node, right? So this function I'm going to create it here, and we'll be passing the parameters, which is node uh, int lh and int rh. Okay, so let's see the logic. If I find the node to be null, I'll be returning 0. Why? Because you have a node and the left half, the right half, there's nothing, so you'll be getting 0, the difference between them. Yeah, and the next thing we are going to do is we're going to find LH with recursion. So length of node, the left half of the node, and I'll be passing left half and the right half. Here I'll be calculating the right half, where I'll be passing node of right, then left, and RH. So here you'll be getting LH and RH through recursion. The next thing I'm going to do is, if the absolute value of LH in RH comes out to be more than 1, then it is unbalanced, which I'll represent by turning -1. And if the left half, if you get it as -1, or the right half you get it as -1, any one of those you get as -1, you'll be returning -1. Because if any one of those is -1, which is unbalanced, the whole binary tree will be unbalanced, right? So at the end, of course, I'll be passing the maximum value between LH and RH plus 1. You need to remember this logic, right? So, and this if length if this length I get it as -1, then it is unbalanced, which is false. Else I'll return it as true, which is balanced. So let's check it here by running. So it has run successfully. Let's submit it and see if all the test cases passed. Yeah, so all the test cases have passed and this code is correct. So that's it. Thank you everyone. Thank you.